Welcome back, everyone. Ready for another deep dive.
Always ready to dive in.
Today, we're going to be taking a look at something that seems pretty straightforward on the surface, order of operations.
Right, the old PEMDAS.
Yep, you got it. But as we dig in, we're going to find out that there's actually a lot more to it than you might think. We'll be exploring how this plays out in, well, how computers think, how understanding order of operations can actually, save you from some coding headaches down the line.
It's true. And what I find really interesting about order of operations is that it's not even just about, math.
It's bigger than that.
Yeah, it gets at a really fundamental logic, a way of thinking that underpins how computers process everything. And honestly, how we think, too, when you get down to it.
Now, that's really interesting. So we're not just talking about, remembering PEMDAS from school.
Right, exactly. PEMDAS is, I guess, kind of like the starting point.
Yeah.
But it's sort of like learning the alphabet and stopping there. You can't actually build sentences with just that. We need to go deeper into what are called precedence rules.
Precedence rules. Okay, so break that down for me. What are those and why are they so important?
So think of a complex equation. Imagine it almost like a sentence, but in this mathematical language.
Okay, I can see that.
Precedence rules tell us which operations we do first, then second, then third, and so on. It's giving us the grammar, basically, for how that mathematical sentence gets evaluated to make sure everything is consistent and accurate.
So there's a hierarchy. Certain operations are more important, kind of outrank others.
Exactly, you got it. And it can actually be really helpful to visualize this hierarchy, which is where the concept of expression trees comes in. Might sound kind of out there, but you can actually represent a simple equation as a tree visually.
Whoa, now that's a new one for me. How does that work?
All right, so let's take a simple one. 1 + 2 × 3. If we picture this as a tree, get this, the multiplication, that would be higher up in the tree, closer to what we call the root, because it's got higher precedence than the plus sign.
Makes sense. So it goes first.
Exactly. And the leaves of our tree, those would be the numbers, the 1, 2, and 3.
So we're building a visual representation of the equation with the most important operation at the top.
You got it. And this is powerful because it lets us see the logic of the expression more clearly. Like with an actual tree, we got to evaluate the branches before we even get to the trunk, you see.
That's a great way to think about it. So where does PEMDAS fit into all of this? Is it just a simpler version of this tree idea?
Yeah, I think you could say that. PEMDAS gives us a basic order, the parentheses first, then the exponents, then multiplication and division together, and lastly, addition and subtraction together. But the expression tree, it helps us understand why that order is there in the first place.
It's like seeing the bigger picture. It's not just memorizing, it's actually understanding the logic.
Right, exactly. And this understanding, it gets especially important when we start talking about programming.
Oh, absolutely. So let's get into that then. What are some of the things about order of operations that are really important for programmers to get right?
So when you're coding, right, it's like you're writing out these really specific instructions for the computer to follow.
Like a recipe.
Exactly. And just like with a recipe, if you mess up the order, things can go wrong. In code, that's where order of operations becomes super important.
So if you don't pay attention to it, you're basically giving the computer a recipe for disaster.
Pretty much. Even one little parenthesis out of place or misunderstanding which operation comes first, it can throw everything off. You get these really unexpected results in your programs.
Wow, so a tiny detail can make a huge difference. Can you give me an example of how that might actually cause problems in real code?
Sure, yeah. Let's say you're building a financial app.
Right.
Something that calculates interest rates.
Okay, high stakes.
Right. And you've got this formula in there. It's got multiplication, addition, maybe even exponents. If the order those operations happen in is wrong, those interest payments, they could be way off.
Oh, no, that's not good. So a misplaced parenthesis could cost someone a lot of money.
Exactly. And it's not just about money even. Think about software that controls important stuff, traffic lights, medical equipment.
That's kind of scary.
Yeah, you don't want order of operations messed up in those systems. It could have some serious consequences.
Okay, I'm convinced order of operations is important. So how do we avoid messing it up? You mentioned parentheses earlier. Those seem key.
Parentheses are like your secret weapon when it comes to writing code that's super clear. No room for the computer to misunderstand. Even if they're not technically needed in a spot, using them more often can make your code way easier for you to understand later and anyone else who might have to read it.
So it's about being extra clear, like adding punctuation to a sentence.
Exactly. Punctuation for code, that's parentheses. And there are other things you could do too, like sometimes you have these really big, complex expressions, right? Breaking those down into smaller chunks can make it easier to see the order of operations.
Yeah, sometimes you can just get lost in the weeds when it's one big, long equation.
Totally. And another good tip is to be consistent with how you indent your code, how you format everything. That visual structure helps you spot potential problems more easily.
It's like writing an outline before you write an essay. Helps you see the flow of ideas.
Perfect analogy. And speaking of seeing things clearly, remember those expression trees we talked about earlier? Those can be super helpful when you're trying to find errors in your code or just understand how the computer's reading it.
Oh, right. So if my code's acting weird, I can actually draw it out as a tree to see if I messed up the order of operations.
Exactly. It's like you're putting on X-ray glasses, you can see the skeleton of your code.
That's amazing. So a tree, which seems so abstract, is actually a really practical tool for programmers.
It just goes to show you, visualization is powerful stuff. It helps us make sense of complicated things. But what's even cooler is that this whole order of operations thing, it goes way beyond just math and computers.
Really?
Ah.
How so? Really? How so?
Well, think about it. Like in our everyday lives, we're always getting hit with all this information, right? Making decisions, big and small, all the time.
That's for sure.
And whether it's just planning our day or trying to understand the news or even just having a conversation, there's this kind of hidden order of operations going on in our brains. It's how we process stuff, how we figure out what to focus on.
So you're saying our brains are like mini computers, always running calculations, following these rules?
Kinda, yeah. Like imagine you're reading a news article, right? The headline, that's designed to grab your attention, and it might present info in a way that's meant to emphasize a certain angle.
Oh, yeah, for sure.
But then, when you actually read the whole thing, get the context, all the supporting details, you're using your brain's order of operations to get the full picture.
That's a really good point. It's like those clickbaity headlines, you know? Totally different first impression than when you read the whole thing and see what they actually meant.
Exactly. Or think about making a decision where you've got a bunch of pros and cons. You don't treat them all equally, right? You naturally prioritize some over others based on what you value, what your goals are. That's your personal order of operations at work.
So just like in coding, where knowing order of operations helps you avoid bugs, in our own lives, being aware of it can help us make better decisions.
Exactly. If we can recognize our own biases, question what we think we know, try to see things from different angles, all of that helps us refine our mental order of operations so we can make smarter choices.
Wow, this has been really eye-opening. I never would have thought that something like order of operations, which I always thought of as just a math thing, could be so relevant to how we live our lives.
It's amazing, isn't it? These fundamental principles, like order of operations, they pop up everywhere, from the complex algorithms running our digital world to the way our own minds work.
It really makes you realize there's always more to learn, more connections to be made, and sometimes the simplest things can unlock a whole new level of understanding.
I couldn't have said it better myself.
Well, on that note, we'll leave you all with this to ponder. What other areas of your life could benefit from a little more order of operations? How can you fine-tune your own thought processes to become a sharper thinker, a better learner, a more decisive person? Until next time, keep those minds curious and happy exploring.